Hi. Hello everyone. Hi. Okay. How are you guys? Hmm? And welcome you all to day. Just a second, guys. Okay. So let me just put up here. Okay. So hi and hello everyone. Welcome to day 6 of our daily coding journey, where we code until we crack a job. Until we get a job, okay, until we feel confident about ourselves, until we feel great about ourselves, until we can say about ourselves that we are not really are scared of DSA anymore. Okay, so this is a journey, this is a live video series where we uh, basically want to reduce our fear to nothing. And I welcome you all to this day 6. Today we will be continuing with the same array series that was left in the master sheet that we were working on. Okay, and once we did this, it will be very easy for us to actually summarize and complete all those other data structures as well. For example, we can do the hash tables, then we can do the two pointer prefix sum sliding window, and this will be done like very fast. Okay, then we will have the linked list and ones. Okay, so this will be where we can do these things as well. Then we have stacks, and then we have queues. After we done like stacks and queues, we will have binary search for us as well. And once we do binary search, then things become very easy for us. Then we can do trees as well. After we do trees, after we do properties and problems of the trees, then we can do heaps and priority queues. And after this, we can do the intervals and all. And after we do this, then the actual task begins for us, right? Then we can do the DFS and BFS. And after we actually do DFS and BFS, I think things become very easy for us from the path ahead, because DFS and BFS perform a very intuitive kind of operations on each thing. So after we do DFS and BFS, once we get the full crux of all what everything is, we can focus our shift. We can shift a focus to, I believe, to DPs. And once we focus ourselves to high level DP, for example, if I show you something, let me just show you something. Let's go to neatcode.io. Beautiful site, and let's go to roadmap. Now, if you see here, we have arrays and hashing, two pointer stacks, binary search, sliding window, linked list, trees. So we have all these things in order as well, right? For master sheet in here, for example, if we push the master sheet here, then you can see also here, right, that we have arrays, strings, hash tables, two pointers. Then we have prefix sum, sliding window, linked list, slow pointers, queues, binary search. Then we have trees. So we have all those things in order right here. After we go to trees, we have two things here. Then we have heaps and priority queues. After we do this, then we have the intervals, greedy, and once we finish this order. Once we finish this order, then we can move on to this order. So we have backtracking left. So backtracking is a very important concept. So we will be doing backtracking as well. And it is very important to do backtracking because it comes before 1D DP. So you should do 1D DP after you have done backtracking, right? So so this we have, then we have graphs as well. And after we do 1D DP, it becomes very easy for us to move into 2D DP, then bit manipulation, then math and geometry. So this is the order that one should follow, and we will be following this as well. So our target for now is to complete the top tree. Our target for now is to complete the top tree, that is from arrays to trees. And after we do arrays to trees, then we can move to heaps, priority queues, greedy, intervals, and all those things. Because if we solve around like from 1D DP, if we solve these things around to 1D DP and interval, greedy, all those, I think we will be pretty much sorted for our job interviews and well. All right. So I think things become very easy for us now. Okay. We have a pretty good idea of what we are going to do. Okay. Okay. So let's see this. Okay. These are the remaining questions of us that were left. Union, intersection of sorted arrays. We will be doing this. Then we have minimum maximum difference between heights. Then we have factorial of large numbers. Then we have array subset check. Then we have three-way partitioning, minimum swaps to being elements less than k together, minimum operations to make array palindrome. We will be doing this. So today we'll be finishing this, and as per the roadmap, we discussed that tomorrow we will be doing the revision of all the array questions that we did till now. So tomorrow is going to be the revision of full arrays as per the master sheet, because arrays is a very big topic. As you can see here, it is a very big topic. Other topics are kind of small in compared to arrays, and that is why the revision of arrays should be considered a part of I would say a different part of something. It should be it should be considered as well. I say that it should be considered like a different and a separate entity to it. So tomorrow we'll be doing the revision of it, and we will be revising everything what we have learned till now, and you will be surprised to know that except sliding window we have actually covered everything from now. So we have done pretty much of everything. Okay. There's a word search question as well, which is a BFS question. So we will not be doing this. We will be shifting this to the BFS one. And let's try to understand what every question here is for now. And majority element two, we did this. So we have a lot of questions we did in the Macarena repository as well. I'm sorry, it should be, let me just go to it. And Macarena master sheet. Yeah, master sheet. So this was a master sheet that we were solving questions. So we'll be revising the arrays question tomorrow, and then we will be merging every question into the arrays folder after tomorrow. Okay. So yeah, as you can see, clean 100 comments. So we'll be doing work ahead for now. So today's first question is what should we start with? So we have two questions at an intersection of two arrays. It's a good question. We will be doing this first. We'll be doing this. Then we have invalid transactions. It's a beautiful question. Okay. So last time we kind of read the question of the invalid transactions, but today we'll be trying to perform invalid transactions. What are invalid transactions as per in this question, and how can we solve invalid transactions? So we have been given a beautiful question, a design question. So this is a design question. uh, it's not written here, but it's a design based question. We will be designing a particular object yourselves. We'll be naming the transactions as well. So you can do this. I will show you another method which is a faster way. Okay. Some people will use objects here. Some people will try to make objects here of transactions, and then they'll be making a different kind of transaction entity. They will be naming it class transactions, and they will be putting right like they will be putting like string name and all those things. We'll be using the four array method, and then we'll be comparing everything. Okay. Okay, let's move ahead. So you will be given a transactions. Transaction आपको दे रखी है with the name. After name, you have been given minutes of basically doing a transaction. Then we have the price, the amount on which you are doing the transaction, and then you have the location given. And another transaction has been given in the same format, like the name, the time in minutes, the amount, and the location. So you have to find out the invalid transactions, and the invalid transactions are something that if the transaction amount is greater than 1000, it should be invalid transaction. Then if another transaction, for example this transaction and this transaction, if these transactions occur in a gap of less than 60 minutes, then it is also an invalid transaction. And if there are two different locations but the name is same, I'm sorry. So for example, there is MTV here and there is Beijing here. So there are two different locations, MTV here and Beijing here. But the name of two individuals who are performing the transactions are same. That is Alice and Alice. So it's also an invalid transaction. That is why these both are invalid transactions. So we return these two things. Second thing here is, second example is, we have Alice here, we have 20 minutes, then we have 800 rupees, then we have MTV. Second is Alice here, 50 here, then is 1200. So 1200 is automatically greater than the limit of $1000. And so we return Alice 50, 1200 and MTV. Got my point? So we have to return the invalid transactions. Now, what could be the case here? Okay. So how can we do it? First of all, you have to see that this is a string of transactions. Okay. You have to like notify yourself in the very first thing that that it is a string of transactions, and you have to perform the actions on string of transactions. Inside the string of transactions, you have the name, time, amount, and the city, and it's going to be the same in everything. So what can we do here? First of all, you can extract everything out of it. You can extract it, and then you can make an object out of transactions, and then you can solve it. This is the most easy way. This is what we can do. Another thing that we can do is pretty much simple, is we can use four array systems. We can make arrays for everything from the transactions of name, time, amount, and the city of transactions, and then we can solve by basically comparing everything. This is also a way. So we can do in any of those two ways depending on what you may like to perform. Okay. Getting my point? Okay. So let's try the four array method, and then we can see how we can make the objects out of it, and then we can solve that question too. Let's now see how we can do this question. So it's a good question. So let me go into my IntelliJ. Hmm. Let me go into my IntelliJ, and then let's find out the question. We have invalid transactions. Yep. So it's a good question, and we should define the packages right. And I'll tell you also that why do you use static here and while inside it, because you cannot reference a non-static object inside a static inside a static function. So you always have to like provide yourself with the static name. That is a very basic thing, but it should be in your top of your mind. Okay. So let me just remove this, and I'll write with static and paste this. Okay. So invalid transactions we have, then we have to return the list of string. Let me just return null for now, because we are on the cusp of writing code. So let's be very fair. Then I'll remove this. Then we'll write the string of transactions. So if we write a string of transactions, yep, string of transaction, and then we will be writing the code here. So if I'll just copy this, and I'll put this, and I'll put this. Okay. And we'll remove this, and then we'll remove this. Okay. So we have put this. Let me just put up a little space here so it looks good and separated. And once we do this, then we have the invalid transactions of transactions, and then we can, or you can do best is you can just shout everything. Just okay. So you can do invalid transactions of transactions. Okay. So now you have everything on you. So the two ways to do this is by using a static function, that is by using the transaction objects, using the transaction objects, and then you can compare, and then you can compare. And it's difficult to understand, but intuitive. And the second thing, so this is what we call the approach one. So approach one is what, using objects, and then you can do this. So we will be doing the approach two. Approach two is kind of more intuitive for us, so we'll do approach two. And what would the approach two here? Approach two for us is basically that we will be using four array system. So we'll be using four arrays arrays system. Okay. So it will be more intuitive for us to use the whole array system, because it's kind of fast than the um normal one. Okay. So okay. So once you have did this, let me just shut my screen off, and let's start performing the question well. Okay. And let me just remove the, yeah. Enjoy. let's see things what are coming for now. Okay, so let's remove it and instead of playlist trace is equal to new variables. All right, अब हमें चार कंडीशन चेक करनी है इसकी, नेम की, टाइम की, मनी की एंड लोकेशन की। तो we have to check for like if there are like many cases. So the many cases को check करनी पड़ेगी. Then name, time, money and location. Okay, so we have name is equal to name of transactions are 0. Then we have integer parser, then location as well. So for example, if we take if two transactions have different name, then we believe that the name is not good. How do we traverse each time into one? Okay, so that would be the case as well, right? So for example, if we traverse from int I is equal to 0, I less than, and I 1 1 1 1 and all those kind of things. So let me think of something. Oh, sorry. So if we traverse everything from top to bottom, okay, so I guess, we have been traversing the length of the array as wrong. First of all, we should first of all refactor this and extract around method variable constant. That's not a constant. It cannot be a constant. Okay, it should be a constant. So it will be one thing that is called transaction voltage, and then we can do what? Then we can let's change it. Let's change it to n, and then we place execute replace one. Okay, so things are good. Okay, beautiful. So in transaction is the length and equal to the location, string to string, and all those things. So now we have to put everything out of it. So what we can do is we have to make a new string out of it, right? So we'll put a new string that we called as part, and then we can do split. Now we can do the rest of things, name, time, money, location, and all those things. Okay, so we did this. Okay, so we are good. Okay, so let me just run this again on the compiler that we were working on, right? And if we just this time do the same thing, all right, okay, so let's just run this one more time. Okay, so it's giving us cleanly now 20 and 50, and now we can just check if they are like valid and invalid, and we will make all those cases, and once we find valid and invalid cases, then we will just return it. Okay, now it becomes simple comparison for us now. Okay, so let's do the comparison things. Okay, so we will make a new variable, we call it boolean, and the boolean valid is equal to false. Okay, we'll make boolean valid is equal to false, and every time we do boolean valid, we will be making all those things for now. If we find this do not valid for us, then we will add the rest of whole transactions. Okay, so we will be adding the whole transaction list. Okay, so sorry. Okay, so let's make those things. Okay, so for example, if we go because everything is now from int I is equal to int n, we can traverse everything from each time. Okay, so if we find that if name, we have name, time, money and location. So if money, so a very simple thing. Okay, for example, if we find that if name, that if money dot I uh, is greater than 1000, then valid. Okay, so we have valid true. No. We have to find is valid. Is valid is equal to false. No. We have to find is valid is equal to true. Let's make this true, and then we can find is valid is equal to false. Is valid is equal to false. So if money is greater than 1000, then is valid is going to be always going to be what? False. So this is the first case. Every time money is going to be 1000, we don't care. Now the time case. So we have to check the time for very. We have to check time for. How would I say this? We have to check time for the consecutive ones. Okay. So how can we do this? Okay. So for int j is equal to 0. Okay. Int j, and we also have to define and जब तक हमारा is valid है, and is valid, then हमारा केस चलेगा ये वाला. And if names of names of I, if names of I is equal to names of j, then what we can do is, or if we say that let's say that if I is equal to j, then you can, you know what you can do, you can just do continue. Then if names of I is equal to names of j, then we know that or let's add more cases. अगर names of I names of j के equal होता है, Alice and Alice are being equal, तो उसमें और भी तो केस आएंगे. And times time of I minus time of j. Let's put two curly braces also here. Okay. This is an important case. See here. Time greater than 60 हमें लिखाना है. So if times of I minus times of j, and we should also do math.absolute. Math.abs. Again, math.time.abs. Okay. Is greater than 60. Greater than equal to 60. And location of I does not equal to location of j, then also okay, does not equal. Okay, so if and dot equals okay, this one and this one. तो is valid अब क्या हो जाएगा? False. True. Is valid is always going to be true. false, sorry. It's going to be what? False. जब ये सारे केस हमारे चेक हो जाएंगे, जब ये सारे केस हम पार कर लेंगे एंड एवरीथिंग, देन व्हाट वी कैन डू इज, what we can do, then we have to just check, because if is not invalid, or I should just say, for example, we have to put just rest on top of everything. Okay, everything. Now coming back to it, अब हमें निकालना है if is valid case. So if is valid, then what we can do is rest dot add, and what we have to add on this transactions of not n minus 1, we have to add I. And after we do this, then we have to add rest. You have to return rest. Let's run this. For int I is equal to 0, invalid is equal to false, invalid is equal to true, invalid is equal to true, and all right, it works now. Okay, so let's just run this, because we are okay. So let's run this. It's a pretty easy question, but if you just like follow on the part of making objects, then it will become very difficult for you. Okay, it will be worst on time space complexity, but it's still very good. Okay, so it works. Let's see. Wrong answer. Why? Alex 676 260 Bangkok, Bob 656 1366, Alex 3933. Okay, Alex 596 expected. Okay, Bob 656 1366, Bangkok, and Alex 596 1390, and Amsterdam. Okay, all right, let's see here. I know what my code is doing, so it's more than 60. Okay, so its transaction is greater than 60, and then this is 60, so this is not good. Okay, another transaction happening in the same name, we don't care if the same name. First of all, this is untransactional, we put this here, then we have another, then we put Alex here. Okay, we do this as if we do this, then we have 390 and all those things. Why are you putting this everything? We have 1366 and 1996. Now we have also been doing Alex and Bob, Amsterdam and Bangkok. 998 right. Good. And still very good on space complexity as well, because I think the particular reason for this is we are not taking objects and we are directly working with primitive arrays. Okay, so primitive arrays are very fast in comparison to objects, because objects stay on heap. Okay, so it becomes very hard for them to retrieve and work with them. Okay, so I think this is a primary reason, because it's still very good on space and the memory complexity. Okay, so this is what we are. Okay, let's just see what it would do on big O. Let's see what big O gives us. All right, the provided code processes a list of transactions to identify valid ones and based on certain criteria. The code first parses each transaction into separate arrays, which takes O of n times, which is the number of transactions. The main logic involves nested loops. Okay, there is a big O of n square. Each comparison involves constant time operations, string comparisons, integer comparisons. Overall, the dominant factor is the nested loop, which includes time. Okay. The code uses additional arrays to store past transactions, name, time, money, and contribute O n space. The result list rest contains, in the worst case, contains all transactions for the list of the O of n. Other variables with constant space, O space complexity. Okay, so it's big of n square and big of n. And you cannot do it less than big of n square. I think this is pretty much obvious right now. You cannot do it in less than O of n times. You cannot, because there is no way you can track all these items in just single pass. Just see, how are you going to track every item on this one for loop? It's not possible. And if there are like 1,000 items here, you cannot do this. There should be a hint on this. Yeah. Okay, so it's saying us to split this into 4 arrays and all those things. For each transaction, check if it's invalid, and you can do this with just a loop with the help of 4 arrays generated on step 1. At the end, you can perform offense. Yes, see, you cannot do this in form of this, or you can use sorting as well. What about if you sort the time here? You can do sorting on the time here, but it still will give you big of n log n. So it's like not worse than that. Okay. So it's a good question. So it's a very good question. Okay. It's a good question. But the crux is only this part. Only this part is the actual crux, that you have to make 4 arrays and then you have to split all those arrays. Okay. So what you're doing is you are making a string parts, and what you are doing here is you are splitting the transactions of I into 4 parts, which is name, time, money, and location. And after that, what you are doing is you are just running a for loop and you are making a boolean invalid result equal to false. Why are we doing this? We are telling you now, because now we will be doing the conditions here. If the money exceeds 1,000, that is always invalid, is always going to be true. And if not, then what you are going to do? If I is equal to j, then continue, because now we will be doing the operations inside I and j. That is the second part. And once we do this, then if name of I is equal to name of j, and time is also going to be greater than 60, and location equals to this, then also it's going to be invalid. Got my point? Then if is invalid, then rest would add transactions of I. Simple. Alright. So it's a good question. It's a good question. Invalid transactions. Alright. Okay, so now question is, intersection of 2 arrays. Given 2 integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. For example, if nums1 is equal to 495, nums2 94984 94 or 490. Alright, I can see two things here. Number one, I can see here is we can do hashing. So hashing is also going to be good. We can use a count array as well. So if nums1 is equal to nums2 and count is greater than 1, then we can do that also. Okay, so I think hash map is going to be good, because if we make two hash maps, okay, hash map one and hash map two, map one, map two, and constant time lookups can be provided, because if map dot get value is equal to map dot get value 2, then we have to just return the nums of anyone. Okay, we have to just check values as well. Okay, if we have to find a for loop, then we can use the values as well, or we can do is we can use a for loop as well here, because if we find a value 1 and value 2 here, then it is not same. Then what we can do is we can just move the left pointer and the right pointer correctly. So it's a good question. Okay, or it's only 1000, then if num size is equal to num 2, then it's still going to be the same. Okay, so let's try here. Let's see if the code is getting pushed, because it's very important. The code is getting pushed. Okay, so it's getting pushed. Now let us see here that what are we going to do. Okay, let's remove this, and then let's do this. Okay, and the question for us is intersection union intersection. Okay, and we are being given with src dot, we have been given then int array. Okay, we'll be using a list, and then we will be transforming that list into uh, array. I'll show you how we can do this. Okay, and once we do this, then we just have to like copy paste. Once we do this, then we can do return null. Integer can be null, so yeah, it works. Then we have to do this. Int nums1 int nums1 is equal to 1221, and 2 is equal to 2 okay. All right, and once we do this, then we have to do array dot intersection of nums1 and nums2. Okay, so it works well for us. Now then we have to do in rest, so we have to do in array list, and array list of integer. Then we have rest is equal to new array list. Okay, now how can we do this? Let's see two things. Okay, so what we can do here is int n is equal to nums1 dot length, and int n is equal to nums2 dot length. Okay, now what we can do is we can use two for loops there. Let's see the brute force approach for this, which will actually work. Int I is equal to 0 and m is less than 0. Int I less than m, so we can do this just here, and yeah, all right. If nums of I is equal to nums dot j, then rest dot add nums1 dot I. Okay, and once we do this, then we have to return the part, right? So we have to return that rest dot stream map dot int I to I into array. Okay, so let's just see. So it's giving me 22222. All right, I get it why it's giving me nums1 dot I like 22222. So let's m greater than 0. Now let's see. Okay, so it's not working. So it's giving me if nums of I is equal to nums of j, then rest dot contain I. So I think it should be going to be and rest and rest. Okay, rest does not contains uh, nums of nums1 of I. Then rest dot add nums1 dot. All right. So it's simple because we have to check that if nums1 of I is equal to nums1 of j and rest dot does not contain nums1 of I, then we have to add nums1 dot I. Okay. So it removes the duplicates out of it. So once we use this, it should be working because the length here is 1000 only. So we can, so it's telling us on face that you can use, you can use for loop, double for loop. It's a nested loop here question. Okay, so it should be working and it should not stop because it's only 1000 and nested for loops can run very well. Got my point? But it's the worst solution. But does not that does not mean that we cannot run this question. Okay, so this is what I was trying to say, you guys. Let's just use a different thing here. Okay, let's just use a different thing here. I'll just use this here and I'll use approach 1. Okay, so this is what we call a double for loop. This is a brute force approach, but it's still very good. Okay, it's not very bad. Brute force approach, it's not very bad. Okay, the constraints are already telling us on face that you can use a brute force approach on 1000. Constraints tell you everything. Okay, constraints are very good. Constraints is like cheating because they already tell you what kind of thing you can be using here. Now the approach number 2. Look, in this particular approach that we were doing just now, from I to n, and then from j to m, we were checking each time that if nums of I is equal to nums of j. So that was like a lookup that we have to perform every time. What if we can use a constant lookup? So we have to just look for a constant lookup. And for constant lookups, which is the best data set, that is called a hash lookup. Okay, so what we can do is we will be using so you know what we can do is we can use a hash set as well. So let's do a hash set. Okay, and from I is equal to set dot and nums dot. Now we will be doing this second time here. Now this is what we are going to do. If set dot contains nums2 dot I, no, if set dot contains nums2 dot I, yes, then I have to add rest dot add nums2 dot I. Simple. And let's just run this code again. And we have to write the same thing as well here. And if rest1 does not contain here, if set does not contain and rest does not contain nums1 dot I. Sorry. Alright. So this should be working good on the time complexity now. Let's see. Let's see how good is this. Okay. Oh, I'm sorry guys. Okay. Let's just use this. Okay. Now let's see how good is it on the time complexity. Index 4 out of bounds for 3, and if rest does not contain, if we can do rest 2 dot I. Okay, because ये m है, nm में की रेंज छोटी बड़ी होती है आपस में. तो now if we see here, so now a little bit better on this, a little bit better, but it's not very great. because now we are like pushing everything on the space complexity. So we did hash set and we did a hash set constant lookup. Okay, so if we do hash set here on the big O time complexity, the time complexity would be big O of n. So that solution, that is what I want to tell you. See, hash set stored in big O of n, the result lies in rest holds up in minimum of n to m elements, so minimum of n to m. So space complexity is n plus big O of n plus m dominated by the hash set. Okay, so time complexity is big O of n plus m. Why is it big O of n plus m? Because building a hash set from like big O of n, iterating through nums of n to big O of m, which is the length of m of nums2, then for each element in nums2 we are checking if it exists in hash which is big O of 1 on average, then we are checking, so it's like big O of n plus mk. So it's still on a very like on a lowly side. Better, see, it's better than this on the double for loop, but it's still on the this side. Okay, so we can do this better. It's like 1 millisecond faster on this, but the best solution is only using 2 milliseconds. So we can do this faster. How we can do this faster? So this is like approach to here. So we can do still better than this. Now we use our two things. We used map 1 and map 2. Okay, let's use map 1 and map 2. Okay, because now this is the third solution that we can be working on. Let's see how the tags are also showing. So now we have the use of 2 pointers. Let's see how 2 pointers can be used here. Suppose my 1 pointer is at this location and my second pointer is at this location. Okay, if I found my this pointer at this pointer, should I move my this pointer to this pointer? It would be useless. So why not move the greatest length of pointer? That is, if nums1 is greater than nums2, then move the left one part. Okay, and the left pointer is going to be the nums1 dot I, and then left pointer is going to be j of that. Okay, so move this, and if nums of I is equal to, if I is equal to j, then what we have to do is rest dot contain, then rest dot add nums dot I, then move this as well and move this as well, and if this contains as well but rest dot already contains this, then just move I, and if this contains, then it already is equal to 0, so move this, and if this is not equal to L, then we have finished, and we have already this. Alright, let's see. So approach number 3 is 2 pointers. Okay, let's see how we can do this. First of all, we have to find out in our main constant on what we are running actually. Okay, so let's find the greatest length. Okay, so int long path is equal to math.max n comma m. Got my point? This is going to be the one. Int I is equal to 0 and j is equal to 0. Now, while I is less than long path, if okay, so let's do this. If n is equal to m, then int long path is equal to math.max is equal to m. Okay, if n is not equal to, then int long path is equal to math.max into rest is equal to n minus long path. No, हमने चूज कौन सा नहीं करा, हम वो कैसे पता लगाएंगे? int long path is equal to math.max n is equal to n and m. then we can do this. Then int, oh sorry, int temp is equal to long path. Okay, if n does not equal to long path, then temp is equal to m. Okay, else temp is equal to n. Got my point? I'm just seeing something. Okay, now while I is less than long path, okay, so you have to find in long path, in long path is equal to 0, in temp is equal to 0, and all right, and j is less than temp. Then what we can do is, if nums of 1 of I is equal to nums of 2 of I, then what we can do here is, then res dot add of nums 1 dot I and I plus plus. Got my point? Else, what would be the else case here? If nums 1 of I is equal to nums dot I and res dot contains nums 1 dot I, is equal to all right. And j plus plus. If nums 1 of I is equal to nums 2 dot I, okay, res dot add nums 1 dot I I plus plus j plus plus. Let's see. Although we haven't used temp here, I just want to see something. Okay, let's see if this would work also or not. Index 3 out of bounds for 3, nums of I is equal to nums of j, and we have also to do j plus plus. Let's see. Or it should be inside the total. If nums of I is equal to nums2 of j and the rest does not contain nums1 dot I, then rest dot contains nums1 dot I. Index 3 out of bounds for length 3. A in j less than contains हमारी इसमें टाइम कॉम्प्लेक्सिटी कितनी आई थी? बिग ऑफ n प्लस m, so the overall time complexity is यार ये हमारा बेस्ट सोल्यूशन था पहले, ये हमारा बेस्ट सोल्यूशन था, बट द पॉइंट इज हम यहाँ पे कंपेयर कर रहे हैं i प्लस आई से, तो हम यहाँ पे कैसे करेंगे यार, कैसे करेंगे हम लोग? तो इसलिए हमें यहाँ पे दो बार स्टार्ट करना पड़ेगा. तो इफ वी डू arrays of sort nums1 arrays dot sort nums2. Alright, so if we sort nums1 and nums2 and while I is less than nums2, so remove this bullshit here. Okay, let's remove this bullshit here, and then we can do I is equal to n, j is equal to m. Alright, and if what came. This would be the worst one. Then all we did. Then all of the solution that we did. Yeah. See, it's still very worst. So what? Yeah, they are doing hashtags. Wow. Good one, but it's still very good one. The one I did. Okay, so I'll just be using this one as well. I'll just be using this one. That's a very good solution. All right. Come and dance me with Mama Karina. With me Macarena, Guantanami, Guantanamo. They all want me, you understand me. I look at them, you Macarena, Macarena. Now you don't you worry about my boyfriend. Everybody know. All right. See, it's still very close. What? Yeah, they're doing hashtags. All right, let's move ahead into a new question. Let's see. All right, we remove this as well. Then union intersection of two arrays, and it's now done. All right. Okay, so next question here is minimize, maximize. Let's do another thing. Okay, factorial of a large number. Game of life. Okay, let's do game of life. Game of life. According to Wikipedia's article, the game of life, also simply known as life, a cellular automation devised by British mathematician John Horton Conway in 1970. The board is made up of m into n grid of cells where each cell has an initial state, live, represented by 1, or dead, represented by a 0. Each cell interacts with 8 neighbors, horizontal, vertical, diagonal, using the 4 rules taken from the Wikipedia article. Any live cell with fewer than two live neighbors dies as is caused by underpopulation. Any live cell with two or three live neighbors lives on to the next generation. Any live cell with more than three live neighbors dies as is by overpopulation. Any dead cell with exactly three live neighbors becomes a live cell as if by reproduction. The next state of the board is determined by applying the above rule simultaneously to every cell in the current board of m into n grid B. In this process, births and deaths occur simultaneously. Given the current state of the board, update the board to reflect its next state. Note that you do not need to return anything. Okay, it's a void question. Yep. Okay. So, for example, if we have 010, 001, 111, and 010, alright, then because I have three dead neighbors aside me, then this becomes dead as well because dead and dead here. And if this becomes dead, then why is it becoming live? Because this is what life is. So this is what life. So this makes this live as well because diagonals are live. Diagonals are live. Okay, so diagonals are live. So this diagonal is live. This diagonal is live. So this makes this live. But this is dead. This is dead. This is dead, and this one is dead. So there are three deads in comparison to one life. This becomes dead as well. Okay, now this makes it dead, this makes it dead, but this makes it live, this makes it live. So live and all those things makes it live as well. Now this makes it dead, this makes it dead, this makes it dead, only this makes it live, so this becomes dead as well. Okay, so we have to make points for everything. Okay, can you solve it in place? Remember that the board needs to be updated simultaneously. You cannot update some cells first and then use their updated values to update other cells. In this question, we represent the board using a 2D array. In principle, the board is infinite, which would cause problems when an active area encroaches upon the border of the array. That is, live cells is the border. So, how would you address these problems? Array matrix simulation. आइए गेम ऑफ लाइफ करें। सबसे पहले हम स्पेस वाला मेथड देखेंगे इसके अंदर भी, जो कि ज़्यादा अच्छा है। एंड देन विल कॉपी बैक द एलिमेंट्स इनटू दिस, सो ज़्यादा दिक्कत नहीं होनी चाहिए। सो स्टैटिक एंड दिस, ओके। गेम ऑफ लाइफ, गेम ऑफ लाइफ, ओके। क्या हो गया? ओके। ऑलराइट, सो पहले देखो। बोर्ड डॉट लेंथ रहेगी और इन टाइम होगी बोर्ड डॉट लेंथ। ये तो हम एक नया बोर्ड बनाएंगे दैट इज कॉल्ड रेस नाम से एक बोर्ड बनाएंगे और इस रेस बोर्ड में हम इन टाइम इक्वल टू एंड देंगे। सो हमें रूल्स पता है गेम के क्या है, हमें डायरेक्शंस चेंज करती रहनी है हर बार। ओके, वी विल हैव टू चेंज डायरेक्शंस ईच टाइम एंड देन वी हैव टू चेक एवरीथिंग। ओके, नाउ डायरेक्शन कॉल्स हमें चेक करनी पड़ेंगी ऑन 4 डिफरेंट पार्ट्स। ओके, तो इफ इट्स अ बॉर्डर तो हमें पहले बॉर्डर चेक करना पड़ेगा आई गेस। पहले हमें रोज की चेक करनी पड़ेंगी, देन कॉलम्स की चेक करनी पड़ेंगी एंड देन वी हैव टू चेक द मिडल वंस एज वेल बिकॉज उसमें हमें 4 डायरेक्शन लेनी पड़ेंगी। तो 4 डायरेक्शन कौन कौन सी होंगी? वी हैव 4 डायरेक्शन कौन कौन सी होंगी? इंट, राइट, लेफ्ट, टॉप, बॉटम की। तो बॉटम वगैरह के लिए हमारे पास क्या रहेंगी? इंट -1 डायरेक्शन लेनी पड़ेंगी ना, हमें डायरेक्शन लेनी पड़ेगी, इसकी -1 लेनी पड़ेगी, इसकी +1 लेनी पड़ेगी, उसकी भी +1 लेनी पड़ेगी, इसकी -1 लेनी पड़ेगी। सो -1 -1 +1 +1 इंट, राइट, लेफ्ट उन सबकी। तो हमें डायरेक्शन वेक्टर्स लेने पड़ेंगे। तो इंट डायर, तो हमें डायरेक्शन वेक्टर लेनी पड़ेगी। तो हमें -1 एंड -1 1 and 1. So we'll have to take 4 direction vectors. Then for int is equal to 0, int is equal to 0. No, let's not do this. मुझे इतना पता है कि हमें डायरेक्शन वेक्टर्स लेनी पड़ेंगे, उसके बिना काम नहीं हो पाएगा, वरना हम चेक कैसे करेंगे हर बार? How can we check in constant time complexity what the direction vector of this is going to be? Because you have to traverse every time, no? हाँ, let's make a new direction column. So we'll name it, or we'll just define it as well. So these are what called the directions of our. So directions. So this is the vertical. This is this is the horizontal one. This is the vertical one, and these are all diagonals that can exist. Okay. यार ये क्वेश्चन कितना अच्छा है, लेकिन ये मेरे समझ में नहीं आ रहा 1% भी। 8 enabled horizontal vertical diagonals में करा क्या है? इसमें क्या बोल रहा है यार? neighbors ले ले 0 1 और int is equal to 0 I less than j is equal to there is nothing j so far okay x if I is equal to 0 I less than j ये डायरेक्शन से किससे पूछूं? ये तो मैं अंदर ही बैठी हूँ। आप ऊपर बार बार क्यों बोल रही हैं? नहीं मुझे एक कुलचा दे दो बस, और नहीं खाना मुझे, फिर भूख लग रही है। One more time. सॉरी यार मैं भटक रहा हूँ दिमाग से। भटकना नहीं है। ऑन गेम ऑफ लाइफ हो गया। ऑल द गेम ऑफ लाइफ यहाँ पे हो गया है। आई विल नॉट अपडेट इट हियर बिकॉज I will have to revise it once, so I'll not just update it. Let's see what this question is. Reverse pairs. Can you solve this real interview question? Given an integer array nums, return the number of reverse pairs in the array. A reverse pair is a pair I of j where 0 of I to j to nums length and nums of I is equal to twice of nums of j. Okay. 1 3 वन ऑफ दोज क्वेश्चन जहाँ पे अगर आपको आइडिया 1% का नहीं है तो आप घंटा नहीं उखाड़ सकते इसका, घंटा नहीं उखाड़ सकते आप इसका। तो खैर ये क्वेश्चन भी अच्छा है, इसको हम रिवाइज तो करेंगे। लेट्स डू अ न्यू क्वेश्चन नाउ। इवेंचुअली हमें ये भी डाल देना चाहिए उसके अंदर, ये इम्पोर्टेंट तो ये है ही। तो गेम ऑफ लाइफ, all right. Okay, so we have this reverse pair question. Hmm. आज हमने एक बार भी वो यूज नहीं करा है, आज हमने इस बार यूज कर लिया। थोड़ा समझ के देखते हैं इस क्वेश्चन। ऑल राइट, ऑल राइट। तो all right. So we have been given this question in which a reverse pair is a pair I of j where 0 to length nums j. Okay, so for example, we have this array. That is, we know 1 comma 3 comma 2 comma 3 comma 1. Okay, and what the reverse code is going to be, so we have I of j, that is going to be up to nums dot length. Okay, so we have, so the similar case, so the one case is that I should be less than equal to j. Okay, I'm sorry. So the one case that should be mattering to us is should be equal to j. That is, I should be only going to be the case that where I is only going to be less than equal to j. Okay, so that is one thing. Okay, so from this is why I start and this is why j, then I would have to traverse all these and then I have to find. Okay, so this is one case. Okay, and the second case is very important. That is, if your pointer I is here and your pointer j is probably here. Okay, okay. So I is what 0 and j is what 1, and also you have to determine that nums of I should be greater than 2 times the nums of j. Okay, so it's very important right now that you have to calculate all the pairs from 2 into nums dot j. That is a question that you have to determine very well. Okay, so what can be the cases that can be the possible solutions of this particular question? Okay, let's see. Let's see what can be the possible cases here. For example, if we take 1 comma 4, that is in the given example as well, it is showing you that if we take 1 comma 4, so it's 0 here. Let me take a different color. So if we take 0 here, then we take 4 here. 0 1 2 3 4. 1 comma 4, 1 comma, okay, 1 comma 4. Okay, so it's not going to be this, it's going to be 1 comma 4. So nums of 1 and 1 comma 4, so it's 1 and 4. Okay, so I is what? I is less than j, that is 1 is less than 4. True. And nums of I is greater than twice of nums of j. So nums of I is 3, that is 3 nums of 1. And is it greater than 2 times of 1? So yes, we know that nums is 3 is greater than 2. So we have a valid case here. What can be the more, what can be another possible case here? What more possible case can be here? If we have another case, for example, when I is equal to 3 and j is equal to 4. So again, I is less than j, that is 3 is less than 4, and 3 is greater than twice of this. So we have 3 greater than 2. Then we also have a valid case. So we have two valid cases here. That we have 1 here and then we 2 here, and so we return answer. So answer is equal to 2. That is what we find in the valid case here. See, it is also showing us the same thing. So valid cases are what? So answer is what? 2 here. Now the thing is, how are we going to determine these points? So a major case that you might be all thinking of is that we can take maybe 2 pointers something. Okay, so we have seen two things, that is a 2 pointer, because we have seen two things, that is I and j. So the basic mindset of ours is we are going to maybe apply a 2 pointer situation here. Now the correct situation would be if we put I is here and j here, and if we traverse both of them into one part. Okay, if we traverse both of them into one part, then maybe the case that if we let us maybe suppose that let me just clear this all out. So we understood what the example of 2 is. We understood what the question is actually asking us, right? let us see one more thing here and how we can actually going to perform this. Okay, so suppose we have 1, 3, 2, 3 and 1. Okay, we take 2 pointers here. We take I at this and then we take J at this. Okay, how can we going to traverse this? So for example, if we maybe traverse, we have I 1 and J 1, so the case is always going to be, so we have successfully transferred the case that I is always going to be greater than J. That is the one case that we are going to always think of. So this case is always and always valid until and unless J and all this cross. So the while loop breaks and we are out of the answer. Now the case occurs that we have to now compare elements. Okay. So the compare elements question is going to be what? So if nums of I is greater than twice of nums of J, then we can return the answer that we don't find it. So what we can do is we can just maybe traverse I plus plus. So suppose we traverse I plus plus here. We traverse I plus plus here. Then we find 3 here. Then we traverse this again. And yes, we find the correct answer. Then what we can do here is we can traverse this. We can traverse this, and hence when we go through the entire array, then we can find that the J is completely in our situation that we have find the correct answer. That is twice of 1. Another thing that we can do is that once we do this, then we can maybe reduce the, then after we have traversed through this, then we can reduce J here, then we can come back from J here, and then we can traverse this from this side as well again, then from J, from J, from J. So the idea is to reduce J every time while we are traversing. So this is not a standard 2-pointer solution as well, because even if you like, for example, 1 3 2 3 1, for example you do this. Okay, for example you do this, and what you can do here is, for example, you put I here, you put J here. Okay, and you traverse this, you do not find any particular match, so you move I here. Now you find a particular pair, so what you can do, you can move forward J and you can move forward I. Now you see that this condition is not valid, so what you can do is move J, so you find 2 and 3 here, which is not a valid situation. So I cross J, I is crossed in J. So what you can do is we can cancel the situation. Now this is not good. Now this is not good, because now the points are not in the correct position. So what we can happen here? So this is not giving us the correct solution. Okay, so 2 pointers is not a valid solution here. 2 pointers is not a valid solution here. Why? Because even if you cross I and J each time, so for example, if you try to think like this, okay, for example, you try to think like this, 1 3 2 3 1, and all this stuff, 1 3 2 3, and you try to think like this. Lakshay, let's do what? Let's do this. Okay, so we take I here, let's do J here, and we traverse this whole entire array, and then we find 2 here. Okay, and for this number we find 2 here, and you say that, Lakshay, you know what, we have did this, this particular case is not being solved. So what you can do is you can move to J. You can now what you can Lakshay, you know what, you can just put J here, and then we can reset I to basically 0, and then we can just traverse full time, and then this, and then again, and then J and J and J. So anytime when I is equal to J, so we know that the condition of the while loop is completely false. So can you see this? You are traversing the entire array 1 time, then 2 times, then 3 times, then 4 times, then 5 times, then 6 times, then 7 times, then 8 times, until and unless when I is not equal to J. You're traversing this whole entire array for God knows how many times. So this is not a very cool solution, I believe. Why this is not a very cool solution? Because it is taking maybe into n times, because you are traversing this like you're crossing like n into n times, and what it is giving you? It is giving you maybe n square, which is a very bad solution. All right. So this is what a brute force solution already suggests us. All right. So 2 pointers does not give us a right solution. Brute force does not give a right solution. What can be the right solution then? Okay. Now this is where the point lies on how we can actually transform this entire array. See, the point of this question is, if you have to find out if nums of I is greater than twice of j, then the one thing that you can actually follow by rules is that you can maybe either sort the array. If you cannot sort the array in the primary place because the nums because the ij positions are very valid, then what would be the case here that you can actually traverse the whole array without entirely looking up into solutions. So the basic thing again is look for solutions. So let me just try out things something. Okay. So for example, we have I 0, 1 0, 3 1, 2 3 3 1 4. Okay. So for example, we have this, and this is a hash map. Okay. So a hash map is showing all those kinds of values. And if we traverse this entire array, for example, and if we see the if we find the map dot is less than map dot and that map dot is the value one, and we traversing it array, then we can try to do like this. Let's just let's just let's just try things. Okay, let's just try things. Okay, we don't know how much point we are going to take care of this, so let's just try things and then we can uh, think like this factorial of a large number. I don't want to do this. Okay. Let's see more questions. We minimize. Difference between heights. Okay, so let's just see now what we were doing here. What we were doing here, I was like bringing up questions here. Okay, so minimize maximum difference between the heights. Okay, let's just put this here and the reverse pair. I'll just put it to put this. Okay, now what we have this minimum operations to make array palindrome. Okay, so minimum operation array palindrome. Yeah, I guess this was the question. Okay, yeah, to make array palindrome, right? To make an array palindrome. Okay, so we will do this as well. Okay, then we have maximum area of a cake, word search. We are not going to do word search, I told you already. Then we have array subset check, three-way partitioning. So we have like 2 more hours left. We have to do these questions very fast. Minimum swaps to bring k less than k together. A together. Okay. Yeah. All right. So we'll do these 4 questions for now, and then we have left this. So yeah, let's leave for now. We'll do this one other time, but tomorrow we will be doing revision for now. Okay, we will be doing revision. There's no way. Okay, array subset check. Check if an array is a subset of this entire array. Okay. Okay, we'll do this as well. Array subset check, and yeah, let's do these 5 for now. Okay, this is going to take a time for us now, and tomorrow we 5 question बचेंगे फिर array. Okay. So this is not a major problem for now. Okay, let's go back to this question. Int reverse pairs. Okay, this is a good question. This is a good question. Good question. Good question. Okay, let's try things here. Okay. Or you know what, let's complete maybe all those questions and then we can come back to reverse pairs. Yeah, we can do this. Okay, let's go to this question. Okay, let's finish some of these questions and then we can come back to the original question that we were supposed to do. Let's find this question first. Array subset. Yeah, array subset check. Okay, and src dot. Okay, public boolean, then you have to return the boolean function out of it, then we have to check this. Okay, so this is some problem here, and then we will have to do yeah, this here we have to boolean check, and then you have to return maybe false. Right. Right. Okay. Okay. Let's quickly finish this question now. And int b is equal to int b is equal to 113717 113 1137. Okay, 113717. This is 113717. Okay, so now we have to find out is this a subset of this or not. Okay, so static, and then we have to return the value, the answer. Okay, so we'll just have to sout. So sout everything is subset here. Now the first thing that you can see here is, okay, now the first thing you can see here is you have to find out that if A is a subset of 2, so we have to check every element of this and every element of this, and if the element contains this and this, then we have to say that yes, you know what, the element of this contains in this, so you can actually return the answer. All right, now how can you do this question? How can you do this question? Right, see, we can do this question by you know what, we can do this question by, because you have to check that an array you just when if B is a subset of A, so you have to check that if B is a subset of A. So you can do what, you can basically count the frequencies element considering in A minus B, and if B is all 0, then you can do what, you can actually return the answer. But the problem is that even if you traverse the elements of A and B inside, the length of the A can be greater than B. It is not you correctly said that if A is equal to B, so counting frequency is not going to be a correct solution. And what we can do next is we can maybe apply a brute force approach. Then it's not going to also work. Let's try hashing here. And what we can do is we can put these elements inside it and run a for loop on this. And we have to check just that if hash contains nums of I, then you know what, we found the answer. And if we found the answer and the value of size is greater than k, then we have to, you know what, we have to remove the elements out of the hash map as well. Okay, so because you know what, if you find an answer k and that it's only the correct one, and if like 3-4 times, for example, there are like 7 times k here. Okay, for example, if it is like 1 time k, for example, if it's like 1 time 7 here and you have like 2 times 7 here. Okay, so you check inside the hash map, it will find 7. Okay, you know what, it is yes, but it is not, because the 7 is already like 2 times here and we have to only find out for like 1 time. So you have to remove the elements outside the size of the carry. So this is a good question, because you have to like check the times the frequencies are coming out of the hash map, right? You have to like minus out properly. So hash map. So you know what, if n is equal, int is equal to a dot length and int f is equal to a. Okay, so we have to take a hash map. Hash map. So hash map is going to be what? Hash map is going to be storing integer, comma, is equal to new hash map. Now you are going to put everything inside it. So map dot put a of I to b of I, a of I to b of I. Return true, else return false. Let's run this. Yeah, what was I thinking? Alright, let's do something that if I, you know what, I put maybe 3 times 3 here, 7 times 7 here. Now it should return me false. It's giving me true this time also, but it is not. So this is not the correct approach. We are going to put only map dot put a comma I comma map dot get or default a of 0 1 or 1. Okay, now for int I is equal to zim, if map dot contains b of I, what you have to do, map dot remove b of I once, map dot remove b of I, map dot remove a of I dot, if map dot contains b of I, then map dot remove value. So we have to remove the key, map dot remove key, map dot remove key. So map dot remove b of I. All right, and all right. And then we have to return maybe. Okay, let's see. It's not working. Why? If map dot contains key b of I. So if map dot contains b of I, so if you find 11, if I find if map dot contains b of I, I think we have to check this map dot key set. Now let's check something. If map dot contains if map.b of key is equal to 1, then if map.get key is equal to 1, then map.remove b of key out of it. Else you know what, if map dot get key, else if map dot get key is greater than 1, then what you can do is map dot remove b of key, and else if map dot key is greater than 1, then map dot remove b of key. Alright, else map look at these elements. अगर डाल रहा है तो BFI के एलिमेंट्स होने चाहिए, तो अगर BFI के एलिमेंट्स डाल दिए इसमें तो पता लगता है इसके थ्रू। अगर BFI के एलिमेंट्स डाल दिए इसके थ्रू, और G ऑपरेटर कर दिया हमने, तो हम कैसे चेक कर सकते हैं? Now we have to check for each time if we found a J here. Okay, so for example, if J is equal to 2 here and we traverse into I, for example, we traverse into 11 7 1 7 21 3 7 3. Okay, so how can we traverse this? 11 7 1 17 13 21 3 7 3. Okay, so how we can traverse this? So now we traverse into this. So for example, Q in A, and we have A here. Okay, A, okay, in num of A. Okay, so it's simple. Okay, now we have to traverse every time that we have to check. Okay, so if map dot contains key num, so what we are going to do is हमें map में से निकालने की तो है value, so map dot put num comma num minus 1. Okay, and if map dot get num is equal to 0, then what we have to do is like map dot remove num out of it. So we have like checked, and if num 1 minus 1 is equal to 0, then we have to like return 1 every time. And thus we have to check every time that if map dot is empty. Okay, okay, so what if we put extra 7 here? That's false. Okay, so it works. Let's now just kindly push this to that. All right. Okay, so we submit this. Okay, so it works. Good question, because you have to like remove the elements each time from it. That's the crux, right? You have to remove the elements out of it, minus the element, and if the num is, then if the key is 0, then remove that element from the map, and you have to just check that if map is empty or not. Simple. So it's good question. And this is what it's saying us, that if I is equal to false, and if b of I is equal to a of j, then you do what found is equal to true, and a of j is equal to -1, mark as visited, and then break in found, then if not found, then return false, and all those things. So it's good. Auxiliary space is big of 1. Then better approach is using sorting and 2 pointer. Sort both arrays and use 2 pointers to traverse them with the current element, and if a is smaller, move the pointer in A. If the elements match, move both pointers if the current element of A is false. Sorry, the sort B and all right. So I think we have successfully done this part as well. So let's remove this. Okay. Now this question is minimum swaps to get k together. So we have been given an array r and number k. One can apply a swap operation on the array any number of times. That is, choose any two index ing and swap array of I and j. Find the minimum number of swaps required to bring all the numbers less than or equal to k together. Find the minimum number of swaps required to bring all the numbers less than or equal to k together. That is, make them a contiguous subarray. Okay. So for example, if you have 2, 1, 5, 3 here, 1, output 1, k is equal to 3. Okay. To bring 2, 1, 3 together, swap index 2 with 4, that is current element, contiguous subarray. K is equal to 3, k is equal to 6. तो समझा ही नहीं है. And number k, one can apply a swap operation on the array any number of times. That is, choose any two index I and j and swap array of I and j. Find the minimum number of swaps required to bring all the numbers less than or equal to k together. Oh, okay. So 2, 1, 3. Okay. So 2, 1 is less than 3, then it is going to be okay. So if k is equal to 6 here, okay, k is equal to 6 here. To bring elements 2, 5, 4 together, swap index 0 with 2, 0 base indexing and index 4 with 6, 0 base indexing, such that the final array will be array of 9, 7, 2, 5, 4, 9, 7, 2, 5, 4, 7, 8. Okay. Then k is equal to 6 here, 0, because we already have this in. Okay. Try more examples. So we have to pick elements which are less than maybe 3, and then we have to like traverse all the elements. Okay, you're given an array and you can integer k, find the minimum number of swaps required to bring all. So you can So we can do, okay, so we have to like swap the elements. Why should we swap the elements first? So if k is equal to 3, then we have to find the minimum way of we can of how we can swap the elements together, right? So we have to like check the window each time, and then we have to like see. So let's take topic tags, data structure, sliding window. So it's like a prefix function. Hmm. All right. So we have to like find the terms. So we have to find out like minimum swap of elements. So we have to like check the elements from the value. We have to like check the. We have to like find the minimum number of elements that is greater than equal to k, right? So so we have to. So let's take two elements. Okay, we take some like good, and we take what, and int bad, and int bad is what equals to. So okay, so you know what we can do. Int n is equal to value dot len, and bad is equal to n minus good. Okay, so this one is good. Okay, so we run for loop. Okay, and if in n is equal to 0, so if array of I is uh, array of I is less than equal to k, then good plus plus. All right. And once we do this, then we have to then good हमें पता लग जाएगा. All right. So we would find out that good क्या होगा, हमें good पता चल जाएगा, and जैसे ही हमें good पता चलेगा bad की value पता चल जाएगी. अब हमें window निकालना है. Okay. So we have to now find the window of size k, right? So now we have to use a fixed size sliding window. So now this is what a fixed size sliding window. All right. So now this is a fixed size sliding window. So in a fixed size sliding window, the first step is take from 0 to k, and then from k to n. Okay. So int bad is equal to 0. All right. अभी के लिए 0 ले लिया इसमें. Okay. So now we'll take from j for int I is equal to 0, I less than k, and I plus plus. Okay. So this is what I is equal to take from here. Now we have to calculate the elements inside this particular array. Then we can remove these elements. Okay. So we can do this either with we can traverse this entire array by once, and we can use the hash map or something as well. So what we can do is we can we don't have any compulsion in this to use a hash map or something. So we can check that if array of I is greater than k, is greater than k, then we have a bad here, and we have a really bad solution here. Okay. We have a really bad solution here, then we have a bad plus plus. Okay. We also have to find out a minimum element. We call it min, and in min we have integer dot max value. Okay. We have to find the integer dot max value. Okay. So all right. So we have a bad plus plus. Okay. So we have all the bad elements inside it. Now while now we have to take the for loop now, that is from k to n. Now from k to n we see that if array of no, we have to remove the elements also, right? We have to remove the elements also from the window. So from k, but if window is But if there are like three elements inside the array, then we have like good is equal to 3, right? So we have good is equal to 3, but what if in 3 here or in 6 here we don't have to like go for window size of 6, because we only have array of maybe for example for 6 here we only have 2 5 4, so we have only 3 elements, so you don't have to like look for 6 elements inside the array, so the window size is not going to be equal to k. Okay, so good intuition. So this is going to be equal to good, and if array of I is equal to k, then we have to find then this. Okay, okay. So now we come into this and we find out that now coming back to the part. Now we have to find that if int left is equal to 0, then for int right is equal to left, right less than good, and right plus plus. Okay, so we have int less than good. Okay, so if we have fixed size writing window, then we have get equal to k. Then if array of right is greater than k, then what we can do is we have bad plus plus. Okay, but if okay, array of right is greater than k, then we have bad plus plus, and if array of left, if array of if array of left array of left if array of left is greater than 2, then we have bad minus minus, and left is going to be equal to plus. So left जितना आगे जाएगा left बढ़ता जाएगा, and solving this, then this would create us min is equal to math dot min right minus left, not right minus left, is equal to going to be equal to bad. Bad तो बढ़ रहा है ना number, so and then we have to return min swap. It's your min. All right, let's see another test case here. 29 2974 29. Okay, also there's going to be one more case here, then that if good is equal to 0 or good is equal to n, then what we have to return, what should we return? Then return 0 because there is no swap required, right? Then okay, let's just yeah. All right, compile, let's see. We have 2 3 4 and 5, 3 4 5, and if we reverse on This is a very good question. This is a good question. All right. So there's going to be some changes here. Good and n. All right. And if area of right is going to be equal to b at if area of right is going to be right is plus area of right is equal to a area of right is equal to and this here. Okay. So it now works. All right, it works. All right. All right. So let's do another question here. That is find minimum number of merge operations to make an array parent group. Okay. So we have 15 for 15. So if we see this, then 15415. Okay. So array is already parent group, so we do not need any merge operation. And if array 1451, then it is yeah. So we can make array parent group with minimum one merging 4 and 5 to make 9, and if 10 4 15 we need to merge all elements to make a parent group. We need to merge all elements. I need to merge all elements. Okay. Oh, okay. So okay, let me see a calculator here. 11 plus 14 plus 15 plus 99, it's going to be 139. To make an the only allowed operation is merging of two adjacent elements. Merging two adjacent elements means replacing with their sum. The task is to find the minimum number of merge operations to make an array pattern. To make an array pattern, we can simply merge them and pattern their array size of array. Okay, we need to we need to merge all elements only to make the adjacent elements. Okay, adjacent elements, we have to make we have to minimum one merging 4 and 5 to make 9. Okay, minimum one merge, all elements merging. Okay, 11 14 15 19 and then merging. So we need to merge all elements to make a palindrome. So 1 1. Okay, so it's 2 9 1 1 2 9 1 1 2 9 9 9 1 1 1 2 9 9 9. Merge all elements to make a palindrome. 11 14 15 and 19. 293 139. It's not same. Then let I of j is equal to minimum number. by the way. All right. To find the minimum number of operations to make an array. Okay, find the minimum number of merge operations to make an array palindrome. Given a number of positive array, we need to make the given array palindrome. The only allowed operation is merging of two adjacent elements. Merging two adjacent elements means replacing with their sum. The task is to find the minimum number of merge operations required to make the array a palindrome. To make any array palindrome, we can simply merge operation n minus one time where n is a size of the because a single element in that case the array will be reduced to one. But in this case, we are asked to do it in the minimum number of operations. Okay, so int I is equal to 0 and j is equal to less than array of j minus 1. Then if we can do if array of is equal to array of j minus 1, then what we can do is we can I plus plus and j minus minus. Okay, but if they are not equal, then else if array of I is less than equal to 0, then array of I plus equal to array of I plus 1 and I plus plus else alright. So if it is like 1 4 5 1, then if these are like equal, then we move both these ahead. Then if array of I is not equal to array of j, then we can only merge together. Okay, then we can merge. Then array of I is equal to array of I plus 1. I plus 1 करना चाहिए, क्या करना चाहिए? For example, if the array is 1, 4, 6, 7, 8, 1. Okay, now the I array index is खत्म, तो हम लोग अभी 4 और 8 पे है. Now if we are on 4 or 8, then they are both not similar. उस केस में क्या करना चाहिए? क्या करना चाहिए? तो इन दोनों को प्लस कर देना चाहिए. So for example, if we do this, if we plus this, then it's going to be 10. तो next operation क्या बनेगा? Next operation क्या बनेगा? 1, 10 and 7, 8. And then 1. Okay, 1, 10, 7, 8, 1. Right, and then we do this as well, and then and j is already on this position because we are not moving j right here. तो ये हो जाएगा maybe 1, ये हो जाएगा maybe 1 and 10 and then 15 and then 1. Okay, and because we are still on j here, then else, and j is already on this position, so we have this. It is still not a palindrome because it is not equal to this. Then what we can do, that we can only merge this together. Then it is 1 and 2 and 25 and then 1 1 2 5 1 and 1 5 to 1, so it's not equal to that. Else else if is equal to this is 1 1, then this. Okay, then we have to find the minimum number of operations. Let's try to see what it looks like in debugging. Then this, and this, and then we return this. Okay, so let's debug this. Okay, let's see what debugging looks like here. Okay, so we have 11 14 99 11. Okay, so I is equal to j. So is I is equal to j? Now it is not. So what we can do is we are on the next stage here. Okay, so if array of I is less than array of j, then what is happening? If array of I is less than array of j, if 11 is less than 99, right? So we are going to I plus plus, then I is going to be what, on 1. Array of I right now is going to be array of I plus array of I minus 1. That is next going to be equal to 25 50 99. That is right. So it's going to be 11 25 15 99. Now next is going to be what? Now while I is equal to j, it's still array of I is equal to j. Now it's not equal. No, it's not equal. Now 25 is less than array of j. Yes, it's going to be equal to array of j. Then it's going to be again 11 25 40. Then array of I is equal to 1. Now 22. Then still the same answer, 139. Got my point? Then now array of I is 3 and array of j is equal to 3. Now it's false. Then return answer 3. Okay, got my point? So this is not making a palindrome, but we have to like merge all operations to get inside a palindrome. Okay, let's see the previous example we were doing so well. Okay, let me again I1 j3. Then if it's equal to 1, then I plus plus j minus minus, then equal to what? So array of I is less than I equal to 2. Then no, it's not equal. Is we going to merge these two together. Then array of 4 9 1. Okay. So it's a stupid question, to be honest. Okay, let's remove this. It's not a cool question. It's just, some shitty question that we just bothered to solve. Okay, so we did this, remove this. Now let's do reverse pairs. We still have that okay, minimize the height question, but let's do reverse pairs now. Okay, it's close to 1 hours now. Yeah, it's 1 hours now, complete 1 hour. So let's do reverse pairs for 1 hours now. Okay, let's do reverse pairs for 1 hours now. It's a beautiful question. Okay, let's see. In the previous time we were discussing all the possible calculations on how we can going to solve this. So we have eliminated two things. We have eliminated the two pointer question, we have eliminated two pointers, and we have eliminated the brute force approach. Okay, so this is the bad approach. Okay, we cannot do this, and it is not going to be working for us. For example, if we will doing maybe a two pointer approach here, then it can guarantee us I is less than equal to j, but it will not guarantee us in any position that j is equal to be greater than or what. Okay, so uh, what we can do is, for example, I'll tell you something. Okay, in order to prove that it will not work at all, what we can do is, let's put int I is equal to 0, and let's put j is equal to nums of n minus 1. Then while I is equal to j, then we can say that uh, if nums of I is equal to 2 times of nums of j, then answer plus plus, answer plus plus, also I plus plus, and just return the answer, nothing else. And believe me, it will give me like answer is equal to 2. All right, it's not giving me. Why? Answer plus plus, and okay, while I is equal to 0, nums of I is equal to twice of nums of. Okay, let's do nums of, or we can do just a simple for loop. Why were we doing this at all at these all times? Okay, so we can do just a for loop, and that's what we were saying, right? That's what we were saying, right? Okay, so yeah, it's not working. It's not working. Why? Because j is not moving at anywhere, right? And after we did this, then only we can do, what, j minus minus. And if we just run this right now, oh, then it's going to be nums of j. And if we run this right now, it's going to be giving me 0. But it should not, because the reverse pairs of this is going to be what? If nums of I plus nums of 2 is equal to this, then array of I is going to be what? Is going to be equal to 0, right? So array plus plus, then I plus plus is going to be I plus plus, and that is going to be equal to this. And you know what? J is going to be equal to minus minus, and I is equal to be going to 0. So we are going to reset I again. Then it's still going to be equal to 0. Why? Int I is equal to 0 and j is equal to nums of minus 1. Well, if nums of I is equal to 2 twice of nums of j, then I plus plus, and if not, just j minus minus. Let's debug this. Although this is not going to be answer, this is nowhere close to the answer. But I'm just thinking, what can we do here? Okay. So 0 4, then if nums of I is going to be what, 0 of 4. Oh, sorry. Sorry. Is greater than equal to. All right. Is greater than equal to twice of nums of 4. Is going to be twice of nums is greater than equal to. Is greater than. Strictly greater than. Okay. Sorry. Let me just run the for loop again. Okay, it's still giving me 0. Wow. Okay, so let me see just. Okay, twice into nums of j. Okay, so if 0 and 4, then 0 and 4, no, it's not equal to 0 of j, then what we can do is then j minus minus. Oh, okay, then we can, you know what, we can, you know, do j minus minus, and then you can, you know what, you can do I plus plus. Okay, so we do not want, then, you know, I plus plus, and I is equal to 1, j is equal to 4, then we found the first element, answer is going to be 1, then j is equal to 4, then it's going to be equal to 3, I plus 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 plus, and answer is giving us, you know, only just 1. Why? Because we were resetting j every time, right? We were resetting j every time. So for example, if you remove this, okay, and you just go ahead with just maybe I plus plus, you're never reducing j minus minus, then what's going to happen? Then it's going to return 2, but it's not a great solution, and it's not going to work in real time. Getting my point? So for example, if I just paste the solution right here, and see where it fails. See, 5 4 3 2 1. Okay, can you getting my point? The output is 3, but it is expecting, you know, 4. Why is it expecting 4 right here? If 5, oh, you know what, let's debug this. Let's debug this. Let's see, why is it failing? 3 2 1. All right, let's debug this. Why? See, I is equal to 0, j is equal to 4, then what? Then if nums of I is going to be equal to what? And you know, if we reduce this and, you know, do j minus minus, it's not going to be updating anything, right? It's not going to be updating anything. That is why, because it only works in one for loop and it doesn't work in anywhere else, because it's going to only work in 0 to 4. That's it. That's like a simple for loop written in just a while loop. See, into 0 is equal to 4, there is not a single element here which is only working, so it's going to find what, 3 elements maybe here. See, twice, it's going to find 5 4 3, right? J is always, like, see, j is always going to be equal to 4. J is never reducing itself. J is never reducing itself in last. That is the problem. this is what a for loop comes in, right? So let's replace this all with a for loop. Let's replace this. Okay, let's do two for loops. Okay, int I is equal to 0, I less than nums dot length. And why is it failing every time, right? Nums dot length or I plus plus. So we have this. Okay. Okay. What's the problem? Oh, this. Forget this. Okay. And if we take a second loop, okay, so we take a second loop, for example, int j plus 1, I plus 1, and all those things. So if and it will work, but it's not a good solution. If nums of I is greater than twice nums of twice and it's going to be L nums dot j, then what you have to return? Answer plus plus. Answer plus plus. Why is it? Oh, sorry. Yep. Oh, sorry. Okay. Yes. And return answer. Stop all. Giving me 4. It will work, but it will fail right now. See, it will give me TLE. It will give me TLE. But it's still a good try, right? Go from basics to what you can actually achieve. Okay. So it's going to give me TLE. Because it's a really bad solution. Yep. And we didn't even gone from like 33 to 140. Like not past 33 test cases, right? Okay, so this is not working. Okay, this is not working. So it was a good try, but useless try. Okay, so let's think of what we can actually think, right? So this solution is going to be actually solved with what we call a merge sort, and we're going to merge sort, and then we're going to compare halves. Compare elements in halves by 2 pointers. Okay, so we are going to take 2 elements. Okay, we are going to take int left array, and we are going to take a right array. Okay, we are going to take 2 arrays, int left and int right, and we are going to work around on those in that nums array. So we are going to do a merge sort right now. Okay, let's study merge sort. What merge sort teaches us? It's taking us, it's seeing us same thing. Take 2 arrays, int left and int right, find the size of 2 sub arrays to be merged. Getting my point? Thing here is you're going to make Okay, so how we're going to do this? So we are going to make a new function first of all. Let's call it like a private and int merge sort, and it's going to be of int nums. Okay, so int if n is equal to nums minus 2, then if n is equal to then what we can do is we can return 0. Alright, int mid is equal to n by 2. Then int left is going to be what? Int, okay, so let's remove this. This is not required for us. Int left arrays copy of range of what? So it's going to be what? Nums int original int from int 2, int original int from int 2. Okay, so int from, now we have to go to int from. So int from is going to be what? Int 0 comma, and from where? Mid. Alright, and similarly we are going to make a right array. And this is going to be what? Same arrays dot copy of range from where? It's going to be from nums, then from mid, and then from n. Alright, you made two things that is called nums left and nums right. Now we are going to sort these. Okay, so int count and merge sort left plus merge sort right. Okay, so we did this. Now we're going to work around this thing. So we know that if int j is equal to 0, that is on the left hand array. This is okay, so this is on the left hand array. So for int I is equal to 0, I less than, and this is for left dot length, because now we are traversing from left dot length. Now while we are on this part, now this is going to be the part. Now while j is going to be what? From like right dot length, and left dot j is less than, and long of left dot j is greater than, left of I is greater than twice L this right of j. Then after we did this, then we can simply just j plus plus, and what is going to be the count be? So count is going to be the times that j traverses, so count is going to be equal to j, right? And after we do this, then we can just merge back into nums. So we're going to create a sorted method and import static method. No, we are going to we are going to create one. So let's create one. Okay, let's create one. More action. Create method merge in reverse case. Okay, so this is what. Now this is a private merge method, int left and int right. So this is a good one. Okay, so working. So your return statement is still missing. Then you know what? Return merge sort on nums. All right. Static merge sort from static. So we have static private int nums. And then we have to return count of it. Okay, so this is good. And it's still going to be 44. Okay, okay, simple mistakes. Let's see. Works. Space is kind of in a variant, but it still works. Okay, this is a very good question. Let's debug this. Okay, let's debug this. Let's see. Okay, let's go into the crux of this. Okay, so we have int array. Let's see how int array and write are working. Then we will have to go this. Then let's see what's happening inside the for loop as well. Then j plus plus, then count is equal to j, then merge this. And while we on to this, then let's see what's happening here. Okay, let's see here as well. And yes, this. And if everything is added, then still left, then what we have to do, right? Let's debug this. Now let's see. So it's making a left array now. Okay, so left array is going to be what? From array of copy of range from num 0 to what? Mid. So it's made left array and then it made right array. Okay, 3, 2, 1 and 5, 4. Okay, good. Sounds good. Now int count is equal to merge sort of left and merge sort of right. Now it's going to be coming from that to here. Now where do you want to go? Merge sort of left and right. So it's going to say like, okay, so let's go from merge sort of left. Okay, then going to back from here. Now merge sort of left is going to be started. Now int n is equal to nums dot length, because now you are saying that merge sort of left is what? Nums dot length. Now the new nums is what? 5, 4. Okay, so n is equal to what? 1. Okay, array of copy, then left is going to be what? 5 only. Then n is equal to 2, then mid 1. Then again it's going to be saying the same thing. Then do you want to go from merge sort of right, count merge sort of right and left? You want to say? So you're going to say yes. You know what? I will just go. You can say again n is equal to 5, n is equal to 1. Okay, so now n is equal to what? 1. Okay, so now it's going to be creating, right? Okay, you know what? Let's create the count of it. So n is equal to 4, n is equal to 1, then it's going to say, okay, now it came out of loop. Now n is equal to 5 and 4. Now we are on the very brink of something. Okay, so we are on the brink of actually merging elements from left and then from right. Okay, okay, so the left and right has been given as 5 and 4. Let's see. Now if int j is equal to 0, then for loop is started from I to j, left dot length minus 1. Left dot length is only 1. Okay, so 0 to 1, that's only going to get. And while j is less than right dot length, only 1 element, and long left of I is greater than 2, so it's not going to be equal to that. It's false statement, so it's not. So count plus j is equal to 0. You know what, it's just false. And once we did this, then it's not going to work. Then you have to, then merge the left and right. So once we do merge left and right, so it's going to be out of the bounds. Left dot right and j, if left dot I is less than what, right of j, nums dot k plus plus is equal to what, else k plus plus is equal to what, and then left to k minus 1. Okay, so we have added all those elements, and then what, we came out of this. Now return count is equal to what, 0. So it's not working. So now we are going to get on what, we have 4 5, and then we have what, 3 2 1. Now we are on the right side of this. So let's go into the right side now. Right side is what, 3 2 1, n is equal to 3, and n is equal to 3 1. Then it's going to break once again. It's going to break 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 break. Now it's going to be on 3 2 1, then again break, and yes, left 2 right 1. Okay, then it's going to be what on, what I'm going to be giving on this, then 2 1. Now it's going to be, and then it's going to be what, merge 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 merge. It's going to be merging what, 1 number 1 and 2. So now the array is what, 3 1 2. So the array is what, 3 1 2 now. Left 3 right 1 2. Then it's going to be what, 3 1 2. Now left is equal to what, 3, and right is equal to what, 3 2 1. Now it's going to be not equal to that, so it's what, I'm just going to get on 3 1 2. Okay, so it's not working on that, so count is still equal to 0. Then it's going to be what, merging into like 1 2 3 here, and after it merges into 1 2 3, then it's going to be what, I'm going back into count 1 1. Okay, Editorial is here. Thank you. Brute force. Do a detector in the question simply cycle to no, it's not going to work. Binary search tree. In approach 1 for each element type, we search the subarray 0 to I for elements such that their value is greater than 2. In the previous approach, the search is linear. However, we need to make this efficient. Maybe memoization can help. But since we need to compare the elements, we cannot find a linear DP solution. Observe the indices of the elements in the subarray 0 to I. Don't matter as we only require the count. So we can sort the elements from binary search on the subarray. But since the subarray keeps growing as we iterate to the next element, we need a data structure to store the previous result as well as to allow efficient search, preferably log over where binary can be put bed. Refreshing BST. BST is a rooted binary tree where each node is associated with a value and has two distinguishing subtrees, namely left and right subtree. The left subtree contains only the nodes with lower values in the parent value, while the right subtree contains the values voila, this is exactly what is required. So if we store our elements in BST, then we can search the elements larger, thus eliminating the search on smaller elements altogether. Algorithm. Define a node of BST that stores the val and pointers to the left and right. We also need a count of elements, say count G, in the subtree rooted in the current node that are greater than or equal to the current node's value dot G is initialized to 1. For each element left and right, pointers set to null. We define the insert routine that recursively adds the given value as an appropriate leaf node based on comparisons with the node value. Each time the given value is smaller than the node val, we increment the count G and move to the val to the next subtree. While if the val is equal to current node, we simply increment OK. We also require the search routine that gives the count of the number of elements greater than with the must not contain the head. Now we get what we know. Iterate over I from 0 to si minus 1 of now. Search the existing BST from 1 to I is greater than 2 plus 1. Then add the result to count. Insert nums of I into BST and hence subtract the count of the previous one. Let's start with three nums for our algorithm. For our algorithm, we need BST. Okay. BST node dot left and right pointers to left and right subtrees. Okay, pointers to left and right subtrees, then value of the node, then count of the elements that are greater than or equal to the node, count of elements that are greater than or equal to the node, set head equal to null, count equals. Now let's get going to the procedure. Okay, BST is null. Search 3, search 2 into 3 plus 1 0. 3 count G is equal to 1. 5 into 2 plus 1 search 5 into 2 count 0 plus 1 plus 5 is equal to 4. We add this search 2 into 3 plus 1 count 2 into 4 plus 1 1 What's your question? All right. Now let's finish this last question of the day, and tomorrow we'll do revision. Lots of revisions. Okay. All right. All right. So this question is minimize the heights. All right. So given an array denoting heights of n towers and positive okay, for each tower, you must perform exactly one of the following operations exactly once. Increase the height of a tower by k, decrease the height of a tower by k. Okay. Return the minimum possible difference between the heights of the shortest and tallest towers after you have modified each tower. Okay. It is compulsory. It is compulsory for it to do this. So okay, 1 plus k, 10 minus k. If we sort this, for example, 1 5 10 k minus this 2, we have like 9. and अगर 9 ही नेगेटिव हो गया तो कुछ हो ही नहीं सकता, हो ही नहीं सकता। then minimum of 5 minus then int minimum of 5 minus k okay, so okay, so what was that? Minimize. ऑल राइट, तो कैसे पता लगाएं? हमें मिनिमम डिफरेंस निकालना है, जिसमें हमें मिनिमम डिफरेंस निकालना है denoting heights of and positive integer k. For each tower you must perform exactly one of the following operations exactly once: increase the height of a tower by k, decrease the height of a tower by k. Find out the minimum possible difference of between the height of the shortest and tallest towers after you have modified each tower. Okay, पहले तो मुझे पता है कि arrays dot sort, इस पे sort ही करो पहले। अभी sort हो गए सारे, बहुत बढ़िया sort हो गए। मेरे पास आ गए 3 9 12 16 20 sort नहीं रखे हैं। Okay, arrays sorted है। Okay, तो 3 9 12 16 20 okay। अच्छा, मान लो मैं पीछे के सारे एलिमेंट्स में से 3 3 माइनस कर देता हूँ, तो मुझे एक कॉम्बिनेशन दिख रहा है जिसमें मैं सारे एलिमेंट्स को, आगे के एलिमेंट्स को माइनस कर दूं और पीछे के एलिमेंट्स को सबको माइनस कर दूं। मुझे ये तो पता लगाना है कि इनमें क्या क्या होगा। सो फॉर एग्जांपल int check is equal to check is equal to array of array lines minus 1 minus array of 0. Now if check is less than k, if check is less than k, then तो कुछ हो ही नहीं सकता। then हमें क्या करना है? it is compulsory to increase or decrease the height of a tower by k after height of the shortest and tallest tower after you have modified each tower. Okay, so first वाला यही आएगा and देन वी दिस आएगा, तो 17 माइनस 6 कितने हो गए? 11। ओके, तो ये है 11। तो हम क्या कर सकते हैं, कैसे मैं डिसाइड करूं कि ये होगा? अगर मैं 3 माइनस के करूं, int माइनस के इज इक्वल टू array of 0 int min array of 0 min is equal to nums of I, यानी कि मेरा करंट है 3 माइनस array of 0 माइनस k, है ना? तो अगर min array of I का 9 और मुझे क्या मिनिमम होगा? तो मुझे पता है दो चीज़ तो दिख रही है मुझे कि या तो मुझे सॉर्ट करके ही कुछ आसपास का मिलेगा, है ना? तो इंट चेक मैंने अगर करा तो ये -17, तो अगर मेरा चेक की के से छोटा है तो मैं रिटर्न कर दूंगा 0, रिटर्न कर दूंगा मैं माइनस का, केस ही नहीं बना कोई। लेकिन अब मुझे चेक करना है कि फॉर एग्जांपल फॉर int I is equal to 0 I not sorry guys, little cold, really cold in Faridabad right now, from where I'm like recording this video. So first of all, it's not going to be one. Yeah. Now I have to check two things, very important. What is the minimum number of rate that I can actually combine everything? So int min is equal to math dot min, and I have to check array of I or array of I array of 0. Got my point? So array of I minus 0. So if your array of I is always going to be greater than 0, okay, so if array of I minus k, so for example 20 minus 17 is what, greater than 17, and 3 is coming out. So if min is equal to the array of 3, then array of I is equal to array of I minus k, else not, then for example is 3, So else, so if your array, so 9 minus 3, um, so int min is equal to array of I minus k, array of I minus k. तो 9 minus 3 is equal to 6, 6 minus 6 और 3 में से कौन बड़ा हुआ, 3 बड़ा हुआ. तो क्या कर सकते हैं इसमें, 3 बड़ा हुआ, तो फिर हम it's not going well, it's not going well. Int min, int let's say small is equal to array of I minus 0 plus k, and int big, array of length of I minus k. Okay, so if array of I minus k is less than 0, then return, then continue, then return, not continue, continue. Now int min is equal to math dot min small minus array of I minus k, and int max, array of small largest, array of I minus 1 plus k, array of I minus 1 plus k, and your answer should be, answer is going to be there as well. Answer is going to be, or we don't have any answer right now, so we should check it. So your answer is equal to 0, and answer is equal to math dot min answer and return DNS. All right, guys. So thank you so much for watching this video. We'll come again tomorrow with more questions. Tomorrow we'll be revising everything what we have learned till now. And yeah, let me just update the sheet once, and we can end the stream. Okay. So yeah, here we are. Okay. Okay. Hmm. Erase subset check. Done. Minimum swaps to bring K together. Done. Done. Game of life. I will not mark this. It's a good question. मैं इसे दोबारा करूँगा. Maximum area of a cake. Reverse pair. अच्छा क्वेश्चन था ये भी. Reverse pair. Number of zero filled triplets. Rearrange elements by sign. So we have 1, 2, 3, 4, and 5 questions. Factorial of large number. Let's mark it done. Minimum jumps to reach end and minimum and maximum height of difference. We have just seen that. Okay. So now how many questions are left? We have 1, we have 2, 3, 4, and 5, 6. So we should have 6 questions left. So let's just remove this. We have one, two, three, four, five. We have five questions left. Then where is sixth? One, two, increasing triplet subsequence. Okay. Number of zero filled subarrays. Then we have word search. Oh, we are not doing word search, right? So it's merging that too. So yeah, I think that's it for now. And thank you so much for guys for joining in this. We'll come back tomorrow, and we'll just do what we do best, like we do coding. So tomorrow we'll be revising everything from arrays, and we will be starting with strings now. Okay, so we have strings. We have good questions in strings, and yeah, I mean, it's going to be a good thing, right? We have Rabin Karp algorithm, we have KMP algorithm, we have Boy Moore algorithm, and mobile numeric keypad conversion, spill binary string. So it's going to be a good thing. Okay, so yeah, that's it from my side, and thank you so much for watching, and we'll meet again.